So in this last example, we have an area of 4x squared plus 17x plus 15. So again, like we've been doing, we're going to set it up. The quadratic term always goes in the first box. The constant always goes in the last box. And these two boxes have to be the linear terms, so something x and something x. So what's special about these two is it has to add to 17x. Now, this one is actually even harder than the first one, and the reason being is, let's take a look at this 4x squared. You see, if I have an area of 4x squared, I have a lot of options. You see, I could have an x, 4x. I could flip it around, and it could be a 4x here and an x here. And as we learned before, the way we write it does matter because it also affects what goes inside here and here. But not only do I have a 4x and an x that could work, but what about 2x by 2x? So right now, just for that first box, notice how I have 3 options that it could be. Well, then let's take the 15. So if I'm looking at a 15, if I have the constant of the 15, well, again, I could do 1 and 15. I could flip-flop those two around, doing a 15 and a 1. Or I could do a 5 and a 3. Or I could flip-flop those around and do the 3 and the 5. I could even throw in negatives. So what happens, there's got to be an easier approach to this, figuring out what goes on the outside without having to do so much guessing and checking. Because I have 1, 2, 3 options for the first, 1, 2, 3, 4, and then 4 more, that's 8. So I have 8 options for the last. And I can match up this one with that one. I could do all sorts of combinations here. Like those two, and only one set's going to work because it's got to be 17x. These two have to add to 17x. So is there an easier approach? And the answer to that is yes. There is a much easier way. So if you've noticed, we've been doing all the way through a T-chart. Factors of what that add to what. So no matter what, it has to add to the 17. Whatever these two are has to add to the 17x. But instead of it being factors of 15, one way I like to look at it is factors of my outside numbers. My outside numbers here is a 4 and a 15. And so what I'm going to do with these two numbers is I'm going to multiply them together. Factors of 4 times 15, well, 4 times 15 is 60. So factors of 60 that add to 17. So let's start off and list our factors of 60. So 1 and 60, 2 and 30, 3 and 10. Yeah. Wait, sorry. 3 and 20. Miss Green, you can't do your math. 4, will 4 go into 60? Yes, of course, because we just did 4 and 15. Will 5 go into 60? Yes. 5 and 12. What about 6? Yes, we know 6 will. 6 and 10. Will 7 go into 60? No. Will 8 go into 60 evenly? No. Will 9 go into 60 evenly? Let's see. No. So, hey, we've met in the middle. We've now listed all of our factors of 60. So which set are we going to use that's going to add to 17? 1 and 60, there's no way I can get those to add to 17. 2 and 30, not going to work. What about 3 and 20? Will 3 and 20 work? Well, if I do 20 minus 3, that will work. Whoops, put that in the wrong spot. That's going to work, except the only problem is that means my 3 has to be negative, and negative 3 times positive 20 is a negative 60. So that one's not going to work because that gives me a negative product. So that one's not going to work. So what about 4 and 15? No, that one's not going to work. What about, 4 and 15, listen to me. I just crossed out the wrong one, 4 and 15. So what about 5 and 12? Hey, what do you know? 5 plus 12 adds to 17. 5 times 12 gives me 60, so I've got my magic set. Now, if I put a 5 and a 12 here, that's not going to work because 5 times 12 is 60, and we need it to be 15. See, in this situation, the 5 and the 12 is not going to go on the outside. Rather, the 5 and the 12 is going to go on the inside. So what we have is the inside, we've got the area of each box, and now we're going to work backwards to find our dimensions. And to do that, we're going to use GCFs. So let's take 2 at a time. And all I have to do is have a starting place. So what is the GCF of 4x squared and 12x? What's the largest term that these two terms have in common? And the answer is 4x. So then now that I've got my starting place, now I can use multiplication to work around. 4x times what is 4x squared? 4x times x. 4x times what is 12x? 4x times 3. X times what is 5x? X times 5. And 3 times 5 is 15. So notice now I have my dimensions. 4x plus 5 and x plus 3. So could I have used this method in all of them? And the answer is yes. So let's take a look and see if it would have also worked in the first one that we had. So going back to our first example, or not our first example, but the example previous to this one. We had 2x squared plus 5x plus 2. And we used a guess and check approach to figure out what the dimensions were. We still set up our box. This one's going to be the 2x squared. This one's going to be the 2, and this is something x and something x. So we still set up our box. But now we want to work inside out. So we got to figure out what goes here and here. So we're going to use our T-chart. So factors of what that add to what. So regardless, these two have to add to 5x. So now, instead of it being the factors of 2, we are going to multiply the outside numbers here. And 2 times 2 is 4. So we've got to find factors of 4 that add to 5. And so 1 times 4 and 2 times 2. Well, what's the set that's going to add to 5? 1 plus 4. So we've got our magic set. So a 1x and a 4x. Then from there, we're going to go with GCFs. So what is the GCF of 2x squared and 4x? 2x. 2x times what is 2x squared? 2x times x. 2x times what is 4x? 2x times 2. X times what is 1x? X times 1. And 1 times 2 is 2. So it works the same way. 2x plus 1 and x plus 2. What about one of the other ones where we didn't have a leading coefficient? So in one of our other examples, the x squared minus 2x minus 24. Okay, so still we can set up our 2 by 2 box. X squared goes here, negative 24 goes here, something x and something x. So again, like we said, it still regardless has to add to the negative 2x. So now notice how I don't have a number in front of the x squared. Well, when there's not a number there, really there's always that indicated 1. So now I'm going to multiply 1 and negative 24, which is negative 24. So factors of negative 24 that add to negative 2, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Looks like we've met in the middle. So which one's going to be the negative 2? Well, how about the 4 and the 6 when we say 4 minus 6? So now we can work on the inside. One of them's got to be a 4x. One of them's got to be a negative 6x. And then factor out GCFs. So x squared and negative 6x, the only term that they have in common is an x. X times x is x squared. X times negative 6. And x times 4. And then negative 6 times 4 is negative 24. So by multiplying your outside numbers, so I like to say factors of the outside that add to the inside, and then figuring out what that magic set is, putting them inside the boxes, then working your way out with GCFs, it's going to work every single time.